And welcome to the short presentation about the prediction of the net hourly electrical energy output of a combined cycle power plant. This is part of the machine learning for product manager certification. We have an assignment to predict a continuous label, which is the net hourly electrical energy output. This is the target, and we have a set of observation with 4 features. Since this is a continuous numeric target variable, we will need a regression approach, and the output metric to evaluate the performance of this model approach will be a mean squared error, the root mean squared error, the R-squared score, also known as coefficient of determination. For algorithm, we will start with linear regression and possibly random forest regression. We will see. The data analysis, first of all, in order to individuate if there are missing data and valid data, shows that the dataset is clean. And as suggested by the NOAA, the National Oceanic and Atmospheric Administration, we have the heat index, which combines the influence of different factors and can capture the nonlinear relationship between temperature, humidity, and energy. And so we will have a fifth feature, which is improve the performance of our model. So given the data range, we also need to normalize the data because we need to have consistency and uniform scale across the different features, and we want an equal weight and a better accuracy. You can see in the reference the GitHub project where you can see all the code, and this is the output of the normalized data after adding the heat index and normalizing it. These are the diagrams showing the distribution and the relationship between the different features. And now we start with the linear regression. So why we start with a linear regression? Because it's a very straightforward model, can be easily interpreted, so it's transparent. Also, it can be used as a benchmark, being simple and fast. It just whatever other model that are more complex then the linear regression doesn't significantly outperform it, it will not be worth doing it. Since the data diagram, we expect the linear regression model to perform very well, around 80%, and we will now split the data in a train and evaluate and test dataset with a random assignment where the train is between 70 and 80%. So we pick randomly the feature, the observation of the feature to be trained. So, and the elapsed time is very short, the measure prediction is very fast. We have a cross-validation MSE of almost 20, a cross-validation MSE around 4.5, and the cross-validation R squared is 0.93. It all pointed to a good accuracy of the model. The RMSE of 4.42 suggests the prediction are reasonably close to the actual values. See also the residual graph, and it has an excellent score, meaning that 93% of the variance in the data is explained in the model. In other words, the independent variables do a good job of predicting the target. So we check now what exactly the random forest will do. It is, as you can see, much slower. It has a smaller error, and it has a slightly higher 0.96 R squared coefficient. So it also shows a very good accuracy, but it's, despite the small data set, is actually slower, and 96% of the variance in the data is explained by the model. Comparing the two models, and we conclude that for the context of this exercise, the linear regression model is accurate enough. Only in the case where the small increase in accuracy will justify the significant training and prediction cost, it will make sense not to use the linear regression model, but this needs to be evaluated with a specific business case. We now check with the ordinary lists where the formats of this. Why we use it? Because it is a model that aims to find the best fitting line by minimizing the sum of the square difference. It is widely used for its simplicity and interpretability, and it shows that actually the model is statistically significant. If you look at the diagrams, it shows that the model prediction are unbiased across all level of the fit values, and also it shows that the suggestion of the model prediction are close to the actual value. So the conclusion is the linear regression is good enough for this case. These are the references. Said in GitHub, you have the public repository where you can see all my code in Python and even another book. Thank you for your time and take care.